All right, so this section is 11.2 compound interest. And write down a few things and then we'll get to calculating. All right, so for loans of more than a year, the interest paid on the money borrowed is called a compound interest, and the frequency in which interest and then the frequency with which the interest is compounded is called the compounding periods. All right. All right, so compound amount formula, A equal to P times 1 plus R over N raised to the N times T power. And we'll talk about how to put that in the calculator as you go forward. And all of these letters represent the same thing they represented in our last section. A is your future value, P is your principal, R is your rate. Don't forget to convert that to decimals. T is your time in years. And then N is the number of compounding periods per year. All right, so when it comes to compounding periods for n, normally they don't say a number. They normally give you a name. So they will say something like compounded annually, compounded semi-annually, quarterly, monthly, or daily. If that is the case, then n would be equal to 1 for annually, twice or 2 times for semi-annually, 4 times for quarterly. Monthly would be 12 times, and then daily would be 360. Remember, that was Banker's rule. All right, let's look at an example. All right, calculate the compound amount when $10,000 is deposited in an account earning 8% interest compounded semi-annually for 4 years. All right, so you write down the pieces that you know. P is 10,000. R is your 8%. T is 4 years. All right, so make sure we don't have any questions. And it would be, since it's semi-annually, that means it would be 2. right, so now we can plug it into the formula. So you can put it in the calculator this way if you have that type of calculator where you can use your parentheses and everything like that. If not, you have to break down in pieces. So we can do it that way as well. 10,000 still be on the outside. Go ahead and divide that 0.08 by 2. It's 0.04. 2 times 4 is an exponent. Is 8. Add what's in the parentheses. That's 1.04. Wait, raise that 1.04 to the 8th power. Probably have to throw that in the calculator. And then multiply that times 10,000. And that will be your answer. It's how much you will have in account after the 4 years. All right. But just like I said before, you could put in your calculator at this moment and get to this. If you have the calculator that has the parentheses, you can just put, in other words, if you can just type out that box, what's in that box, into your calculator, then you just do that in that form and hit enter. All right, so how much interest is earned in two years on $4,000? Deposit in an account paying 6% interest compounded quarterly. All right, so make sure we note what they are asking for. It says how much interest is earned. So the last one we were dealing with want to know, the compound amount. That's what this formula gave. But if we want to know how much interest is earned, we're going to have to do something extra. So the first thing we want to do is go ahead and establish what are our givens. So we know it's $4,000 for our deposit. It's a rate of 6%. Time is 2 years. And it's compounded quarterly. So that'd be 4. All right, so that's 4,000. 1 plus 0.06 over 4 raised to the 4 times 2. So you put that in the calculator, should get 4,505, and of course 97 cents. So once again, make sure you know how to use your calculator. And if you have any questions about doing so, make sure you get with me so I can help you out. All right. And we talked about this last class. To calculate your interest is A minus P. Take your future value, which is 4505, 97 cents, minus our principal, which was $4,000. And that lets us know how much interest was earned, which was the 505, 97 cents. All right, questions? Any questions? All right, so the present value formula is the same formula we just finished using, except you solve for P, solve for the present value. So if you want to know how much money you should deposit into an account, earn a certain All right, so how much money should be invested in an account that earns 8% interest compounded quarterly in order to have $30,000 in 5 years? So, as always, you write down your givens first. We want to have $30,000, so that's the future value. Your rate is 8%. Time is 5 years. Then N is quarterly. I can't write, a little sloppy. And that's 4. All right, so P is going to be equal to 30,000 over, as a matter of fact, I'll put it where you would have to put it in the calculator. So you put it in the calculator, and it should give you 20,189 and 14 cents. All right, questions? Any questions? Let me see what would be the next good example. All right, I use. Here we got one more example. Oh, we can do this one. All right, so inflation is an economic condition during which there are increases in the cost of goods and services. So suppose your annual salary today is $35,000. You want to know what an equivalent salary will be in 20 years, assuming 6% inflation rate. So always start off with your givens. And then N, your inflation rate is annual. So that means N is equal to 1. And just plug it into the future value formula. So it's 35,000 times 1 plus 0.06 over 1 raised to the 1 times 20 power. And you should come up to 112,249.74 cents. Questions, questions, questions. Let's see one more. All right, so the effective interest rate, the simple interest rate that will yield the same amount of interest after 1 year. All right, so let's see how we will find that. All right, so last problem. Say credit union offers a certificate of deposit at an annual interest rate of 3%, compounded monthly. Find the effective rate. Round to the nearest hundredth of a percent. All right, so we consider $100 after 1 year. I think this stated that credit union offers a certificate of deposit. Yep. So in one of the previous examples, when they explained it, they said consider $100 deposit at a certain amount. So what we'll do is consider $100 and deposit that. My rate is 3%. T is 1 year. After 1 year, and N is monthly. So that's going to be 12 for us. All right. So P is 100. R is 0.03. T is 1 year. And N is monthly. We'll plug it into our future value formula. All right, that will give us 103.04 for our interest, for our future value after that year. All right, then we will calculate the interest earned. Don't forget that's A minus P. So it's 103.04 minus 100. That's 3.04. And so we'll take that and say the effective interest rate is 3.04%. All right. Questions on anything? All right, so that's it for 11.2. Next class, floor will be open for questions. Don't forget that this test is on 10.1 through 10.2, 11.1 through 11.2. And I'll post that review and test shortly, but next class would be on you to ask whatever questions you want to ask. If I can think of something that I see that you guys may be having trouble with, I'll go ahead and pick up, put it down. But if not, I guess we'll look to move forward. But you guys let me know. And don't forget, you can always email me and we can discuss problems through email or set up a another session, individual sessions. So don't forget those opportunities are available for you. And with that being said, if you guys are good, I'm good. And I will see you on next class. Have a good one.